Hello people, today we are going to start with a new series, System Analysis and Design. So let's see. The System Development Life Cycle, also known as SDLC, is composed of four fundamental phases: planning, analysis, design, and implementation. Each of the phases include a set of steps which rely on techniques that produce specific document files that provide understanding about the project. To understand SDLC or System Development Life Cycle, each phase consists of steps that lead to specific deliverables. The system evolves through gradual refinement. Phase 1 is planning. This phase is fundamental process of understanding why an information system should be built. The planning phase will also determine how the project team will go about building the information system. The planning phase is composed of two planning steps: project initiation and project management. During the project initiation, the system business value to the organization is identified. How will it lower cost or increase revenue? The second step in the planning is project management. The project manager creates a work plan, staffs the project, puts techniques in place to help the project team control and direct the project through the entire SDLC or System Development Lifecycle. Phase 2 is analysis. The analysis phase answers the question of who will use the system, what system will do, and where and when it will be used. During this phase, the project team investigates any current systems, identifies improvement opportunities, and develops concepts for the new system. This phase has three analysis steps. The three analysis steps are analysis strategy, requirement gathering, and system proposal. In case of analysis strategy, this is developed to guide the project team's effort. This includes an analysis of current system. In the requirement gathering, the analysis of this information leads to the development of concept for a new system. The concept is used to build a set of analysis models. The last step in the analysis is system proposal. The proposal is presented to the project sponsor and key individuals who decide whether the project should continue to move forward. Next is the requirement analysis. The system proposal or requirement analysis report is the initial deliverable that describes what business requirements the new system should meet. The deliverable from the phase is both an analysis and high-level initial design of the new system. The next step is design. In this phase, it is decided how the system will operate in terms of the hardware, software, network, and infrastructure. The user interface, forms, and reports that will be used, and the specific programs, databases, files that will be needed. The five design steps are design strategy, architecture design, database and file specification, and program design. So first thing is design strategy. This clarifies whether the system will be developed by the company or outside the company. Next is architecture design. This describes the hardware, software, network infrastructure that will be used. Then is database and file specification. This documents define what and where the data will be stored. And the last is program design. Defines what programs need to be written and what they will do. The fourth step is implementation. During this phase, the system is either developed or purchased. In case of packaged software, it is purchased. This phase is usually the longest and most expensive part of the process. The phase has three steps, and the three implementation steps are system construction, installation, and support plan. The system is built and tested to make sure if it performs as designed. In case of installation, they prepare to support the installed system, and support plan includes a post-implementation review. System development methodologies. A methodology is a formalized approach to implementing the SDLC. The methodology will vary depending on whether the emphasis is on business processes or on the data that supports the business. Process-centered methodology. With this methodology, the focus is on defining the activities associated with the system. The concentration is on representing the system concept as a set of processes with information flowing into and out of the processes. Then there is data-centered methodologies. This methodology focuses on defining the content of the data storage containers and how they are organized. Data-centered methodology utilizes data models as the core of the system concept. Then is object-oriented methodology. The methodology attempts to balance the focus between processes and data. The unified modeling language is used to describe the system concept as a collection of objects incorporating both data and processes. Category 1 of the system development methodology, under that is structured design. Let's learn about structured design. Structured design methodology adopt a formal step-by-step approach to the SDLC that moves logically from one phase to the next. This design methodology introduces the use of formal modeling or diagramming techniques to describe a system's basic business processes and follows a basic approach of two structured design categories. Waterfall development. With waterfall development based methodologies, the analyst and users proceed sequentially from one phase to the next. The two key advantages of waterfall development based methodologies are the system requirements are identified long before programming begins, and the next thing is changes to the requirement are minimized as the project proceeds. So this is important for waterfall development. The system requirements are identified long before programming begins, and changes to the requirement are minimized as the project proceeds. The two key disadvantages of waterfall development methodologies are the design must be completely specified before the programming begins. A long time elapses between the completion of system proposal in the analysis phase and the delivery of the system. Waterfall development based methodologies has planning, analysis, design, implementation, and system. So these go in the sequence. They don't overlap in case of waterfall methodologies. Next is the parallel development. This methodology attempts to address the long time interval between the analysis phase and the delivery of the system. A general design of the entire system is performed, and then the project is divided into series of distinct sub-projects. So here you can see the planning begins, then analysis, then design. And design can be again we can again come back for design for different kind of project, like project 1 design and implementation, project 2 design and implementation, project 3 design and implementation. All the sub projects are running in parallel, both design and implementation, and then final implementation of the system takes place. Category 2 of the system development methodology, rapid application development, also called RAD. RAD based methodology adjusts the SDLC phases to get some part of the system developed quickly into the hands of the user. Most RAD or rapid application development based methodology recommend that the analyst use special techniques and computer tools to speed up the analysis, design, and implementation phases, such as CASE, computer aided software engineering tools. One possible subtle problem with RAD based methodology is managing user expectations. Phase development. This methodology breaks the overall system into series of versions that are developed sequentially. The team categorizes the requirement into series of versions, and then the most important and fundamental requirement are bundled into first version of the system. The analysis phase then leads into design and implementation. However, only with the set of requirement identified for the version 1. As each version is completed, team begins work on new version. Phase development based methodology. This is how it works. First is planning, then analysis, and then all the three for the three sub projects or three versions take place, like analysis, design, implementation for system version 1, analysis, design, after this is done system version, then again for version 2, again analysis, design and implementation takes place, we get version 2. Then again for version 3, again analysis, design and development for system 3. So this is how phased development based methodologies work. Prototyping. Prototyping based methodology perform analysis, design, implementation phases concurrently. All three phases are performed repeatedly in a cycle until the system is completed. A prototype is a smaller version of the system with minimal amount of features. Prototyping based methodology. Planning, analysis, design, implementation, then system prototype, and then again go back and do analysis, design, and then final implementation of the system. So first, in case of prototyping, we first develop the system prototype and again go back to do all these three: analysis, design and implementation for the final implementation of the system. Prototyping advantage is provides a system for the user to interact with even if it is not initially ready for use. And disadvantage is often the prototype undergoes such significant changes that many initial design decisions prove to be poor ones. Throwaway prototyping. Methodology are similar for prototyping based methodology. The main difference is that throwaway prototyping is completed during different point in SDLC and has relatively thorough analysis phases. Throwaway prototyping based methodology. Here is the example. It's not visible, so let's expand a little bit. So it's not quite visible, but let me explain it. It's planning, analysis, then we get analysis, design and implementation, and then we develop a throwaway prototype here, and then again we go back to analysis, design and implementation, again design a new, we do a new design for the final implementation to get the system, actual system. Category 3 of the system is development methodology is agile development, which is used currently by most of the company. This category focuses on streamlining the SDLC by eliminating much of the modeling and documentation overhead and time spent on those tasks. Project emphasize simple iterative application development. This category uses extreme programming, which is described here. Extreme programming, also called XP. Extreme programming was founded on the four core values: communication, simplicity, feedback, and courage. The key principles of extreme programming include continuous testing, simple coding, close, uh, close interaction with end users to build systems very quickly. And extreme programming based methodology are planning, then analysis, design, implementation, then when final system is developed, then go back analysis, design, implement. So it goes on. Continuous progressive elaboration takes place in which at every step parallelly we analyze, design and implement. We do it again and again in like iterative kind of thing. Selecting the appropriate development methodology. Selecting a methodology is not simple, as no one methodology is always best. Many organizations have their own standard. So let's see, here is the a table which lists the criteria for selecting a methodology. This is structured methodology, this is rapid application development methodology, this is agile or XP methodology. With unclear requirement, waterfall will be poor, parallel will be poor, phased will be good, prototyping will be excellent, throwaway prototyping will be excellent, and agile methodology will be excellent. With unfamiliar technology, again waterfall and parallel are poor, and prototyping is poor, and agile is obviously poor because the technology we are not familiar. Only throwaway prototyping is excellent, and phased can be good. When it is complex, when the project itself is a complex, then throwaway prototyping is excellent, and waterfall and parallel are good. If ability to develop system are reliable, when it is reliable, throwaway prototyping is excellent, agile is good. With short time schedule, when there is time schedule constraint is there, as agile is always excellent, prototyping and phased is also excellent, throwaway prototyping is good. And with a schedule visibility, the phased and prototyping are excellent, and agile and throwaway prototyping is good. So using this, this is the rule. This is just a random way to find out based on your particular requirement or your project. You can decide which type of methodologies is used to develop a system. So mainly agile is used when there is a short time schedule. Nowadays many companies are using agile methodology because they have a time constraint, a schedule constraint. So for rapid development they use agile technology, in which every phase of the project takes place in parallel and continuous progressive elaboration takes place. Clarity of user requirement. RAD or Rapid Application Development methodology of prototyping and throwaway prototyping are usually more appropriate when user requirements are unclear, as they provide prototypes for user to interact with early in the SDLC. Familiarity with the technology. If the system is designed without some familiarity with base technology, risk increases because the tools may not be capable of doing what is needed. Then is project team skills and role. Project should consist of a variety of skilled individuals in order for the system to be successful. Six major skills an analyst should have include technical, business, analytical, interpersonal, management, and ethical. Categories of analyst can be business analyst, system analyst, infrastructure analyst, change management analyst, and finally the project manager. This one lists the project team roles like business analyst, and the responsibility are analyzing the key business aspects of the system, identifying how the system will provide business value, designing the new business processes and policies. System analysts role responsibility is identifying how technology can improve business processes, designing the new business processes, designing the information system, ensuring the system conforms to the information system standard. Then infrastructure analysis responsibilities are ensuring the system conforms to the infrastructure standard, identifying infrastructure changes needed to support the system. Change management analyst shows developing and executing a change management plan, developing and executing a user training plan. And finally, the role of project manager is managing the team of analysts, programmers, technical writers, and other specialists, developing and monitoring the project plan, assigning resources, and serving as the primary point of contact for the project. So here is the summary for today. The system development lifecycle or SDLC consists of four stages: planning, analysis, design, and implementation. There are six major development methodologies: the waterfall method, the parallel development method, the phase development method, system prototyping, design prototyping, and agile development. There are five major team roles: business analysis, system analyst, infrastructure analyst, change management analyst, and the project manager. So guys, I hope you got some idea on system analysis and design. So come back to my channel for more information on system analysis and design and other geek topics. Thank you very much for watching. See you soon.